Well, welcome back to GIS Analysis at the University of Alaska Fairbanks. In this session, we're going to work with polygons and points in our test raster. So let's make some polygons from our original square polygons. So if we open up the attribute table, let's add a field called code. And then let's select some polygons. It doesn't really matter which ones we select. I'll select these down in the lower left-hand corner. And we'll assign them a value. And it doesn't matter what value it is as long as it's the same value. So I'll just give them an arbitrary number. And then we'll select another set of polygons. So let's select up in the upper right-hand corner these polygons. And we'll give them some arbitrary number. So we've got 9 selected. And we'll give them any value. It doesn't really matter. Okay, so then what we'll do is we'll isolate these polygons that are squares that have a code value. So code greater than or equal to 3. And let's label each polygon with its code value. Oops. So label features in this layer using code. So here we have polygons that have a value of 8 and polygons that have a value of 3. So let's use the dissolve tool to dissolve by code, and then we'll come up with 2 unique polygons. So we'll dissolve based on code. So then that gives us 2 unique polygons. One polygon that has a code of 3 and one polygon that has a code of 8. So we can use these polygons to cut out all the raster cells that are inside these polygons using the clip tool. So there's actually going to be 2 clip tools. So the clip tool in the analysis toolbox is for clipping out points, lines, and polygons. And the clip tool in the data management toolbox is for clipping out rasters. So we're going to clip our raster using our dissolve polygon. And then the final thing we typically will do is check on use the input polygons for clipping geometry. So that way it will cut out exactly what's inside our polygons. So here's our original raster, and here's the raster after running clip. And then if we look inside the raster attribute table, we have the value and count of all the pixels inside this polygon and this polygon. The other thing we might be interested in is what is the minimum pixel value or the maximum pixel value or the mean pixel value inside each polygon. So we can use zonal statistics as table to create a table of all the descriptive statistics from the raster by polygon, where each polygon is a zone. So in this example, our zone is going to be our polygons. And then the field which defines each zone is the field called code. And then our raster is our test raster that's been clipped. And then the statistics. So we can specify what statistics we want. So I'll say give me the mean, minimum, and maximum. And then that will be output to a table of the descriptive statistics inside every zone. So every different code value defines a different zone. So for example, inside the polygon that was code 3, there were 9 grid cells, and the maximum was 100, and the minimum was 78, and the mean was 89. So we can test that because we have the original raster that was derived from the fishnet. So let's add our original fishnet polygons, and then we'll label them to see what the pixel values were created from our original square polygons. So we'll add our fishnet, which was called square polygons, and then we'll label those. So we'll label them based on their original object ID. So then if we look at the table, so here is the polygon that had a code of 3, and the minimum is 78, and the maximum is 100. And here is the polygon that had a code of 8, and the minimum is 1, and the maximum is 23. So it all makes sense. The other thing we might want to do is use points to determine what is the pixel value for every point the pixel is sitting in. So when we originally created our squares from Create Fishnet, we also created label points. So let's add those label points as a layer. And then what we want to know is for every point, what is the pixel value that point is sitting in? So to answer that question, we could use the Extract Values to Points tool. And that's a tool what we might use is our points represent ground truth, and we're comparing ground truth values compared to pixels values, for example, where the pixel value might be a land cover class and the point might actually contain the actual land cover at that location. So we'll use the tool Extract Values to Points, and our input is our point feature class, and the raster is our test raster, and that will create new output points. So I could call this points with pixel value. So for every point, find the pixel the point's sitting in, extract that pixel value, and add it to the point attribute table of this new point feature class. So for example, this point is sitting in a pixel that has a value of 1. This point is sitting in a pixel that has a value of 3. And this point is setting in a pixel that has no data, so it returns null as a value. So typically we're only interested in the points that have valid pixel values, so we can do a definition query. So raster value greater than or equal to 1. So then we would just have the points that have pixel values. So then we have all the points that are 18 points that have valid pixel values.